So this is the second lesson in vectors, and it's still kind of like the introduction and the basic stuff. So basically for vectors, last lesson we learned what a vector exactly is. So if you don't remember, a vector is a magnitude. So a vector is equal to a magnitude of direction. Basically I have this value here, and the magnitude basically is my number. So is it 5? Is it 6? And direction, is it to the south, to the right, to the left, downwards? So an example of this is 5 meters per second to the east. So my direction here is going to be to the east. My magnitude here is going to be 5 meters per second. Now notice meters per second is not part of the direction, it's simply a unit that it refers to how, so what is the 5 representing? Because if you don't have the unit, it might be like 5 meters or 5 liters. So the units here is just to represent what exactly is my magnitude saying about, what is my magnitude referring to. So the magnitude here is going to be 5 meters per second and direction is to the east. So now that we've had a recap of what vectors are, let's just start representing this more algebraically. So let's start with 1D. So we start with 1D vectors. What we do here is we can draw all the vectors out. So we have this 1D coordinate here, which is facing the x direction, and right now we'll assume that our vectors are positive, so they all go in one direction, they all go this way. So if I labeled my coordinates, this would be 0, 1, 2, 3, 4, 5, 6. Okay, so right now let's say I wanted a vector which has a magnitude of 6 and or let's say a magnitude of 4 and is moving in the x direction. So I don't exactly care where I start from, because as long as it has a magnitude of 4 and a direction to the x direction, then it's the same vector. So but let's just start from the origin for simplicity's sake. So we start from the origin, we go 1, 2, 3, 4. Wait, that's what's a bit over. Okay, we can go 1, 2, 3, 4. We have this arrow here to indicate that the direction is to the x direction. Now, if we don't have the arrow, this value here would be 4, right? It's 4 units to the right of the origin. So this is just a scalar. Now that we have an arrow, it's a vector. It has a direction. So this means that the direction also decides whether the vectors are the same or different. So this vector is different as this vector. So how exactly do we represent vectors, or 1D vectors, just for really simple things? So for one-dimensional vectors, we can say, so they're all facing in one direction, right? So we can literally just state the magnitude, and we usually represent vectors as one letter, so we can say we have vector v. You can say we have vector v. Or you can say, so we start at O, we end at, so let's just say this is point O. Or we can say we start at point A and we end at point B. So we can also say vector v or vector AB. Now this arrow here indicates which direction we're going. So vector AB is not equal to vector BA. These are not equal because the direction is different. Okay, so we can represent vectors like this, and basically right now what we can do is we can also, so we know the coordinates of our vector, so we know the magnitude, and for the magnitude we can represent like this. So we add the absolute value, because if we add the absolute value, if you think about it logically, it's basically the distance from the origin, or the distance between. So basically the distance, right? The absolute value usually refers to distance on a number line. So this is going to be the distance of the vector, which is basically like the magnitude of the vector. So basically right now, we can also, so right now we know that vector AB has a length, or its magnitude is going to be 4 units, right? Because we have the coordinates 1, 2, 3, 4. So its magnitude is 4 units, and we want to represent this vector. So how do we do this? So we can represent this vector as, so we first write the, so we only have one dimension, right? So we can just write 4. So you can write it in brackets in these, I don't know, these sides here, or you can write it like this. So it kind of depends on the teacher, the test paper, and also maybe you, or maybe what happens in real life. So now let's talk about 2D vectors. So for 1D vectors, the summary is just that we can represent the magnitude like this for any vector, and we can represent the vector either as a lowercase letter or its 2 endpoints, but both have an arrow on top of it, and the arrow indicates direction. It's not just a display. So we switch the order of the 2 endpoints, then the vector is different. So we can represent our magnitude, our 1D vector like this. There are 3 ways, I believe. So right now we have 2D vectors, and we're going to use the coordinate plane. So I just drew the coordinate plane here. Let's just stick with vectors in the first quadrant. So this is our origin. Say I add 1, 2, 3, 4, 1, 2, 3. Okay, so let's say my vector was, let's see, let me try to draw this. Let's say it was somewhere over, so it starts from the origin. It starts from the origin and it goes to something like this. So this arrow indicates the direction, and you know the difference between 2D and 1D vectors are basically you have a lot of directions. You can rotate the direction 360 degrees. You have so much directions. In 1D you only have one direction. So in this case, let's just assume that this is our vector, and this endpoint here is going to be B, this is going to be A. So right now basically we have, so we can represent this as vector V or vector AB. So we want to work out the magnitude, because as you can see here, we used magnitude to represent our part of our vector. So the magnitude can be still written as absolute value around vector V, and or also the absolute value on vector AB. So in this case, we can use the Pythagorean theorem. So if I just drew this line here and I have a right angle triangle, I can use the Pythagorean theorem to figure out the length of AB. So length of AB here, regardless of the direction, is going to be root 4 squared plus 3 squared. So the length in the x direction plus the y direction squared, and you take the root of that. That is 16 plus 9, which is root 25, which is 5. So the absolute value is, or the magnitude is 5. So we have the magnitude, and we're thinking about how we can represent our vector that is 2-dimensional. So for 2-dimensional vectors, we have 2 variables here. So we represent how much our coordinate, our vector has went in the x direction, and we also represent how much it has went in the y direction. So basically right now we first state the x direction. Basically the x direction, we move 4 units, right? So in the x direction we moved 4 units. In the y direction we moved 3 units. You can also state it as 4, 3, or in this form, 4, 3. So this is our 2-dimensional vector, and for our 3-dimensional vector, it's just essentially the same thing, so maybe I should show you too. So we have 3D vectors. So if I just drew the 3D coordinate plane here, this is the z-axis, So this is the z-axis, this is the y-axis, this is the x-axis, and we're only going to use the first quadrant right now. So 3D is harder to visualize, but not that hard because objects in real life are 3D. But if we know the basics, we can use vectors in 4D, 5D, even maybe 20D or 30D, dimensions, which are really hard to visualize. But right now, let's just draw the 3D vector. So let's say my vector was, I'm going to use green. Something like this, and just to make it clear, I'm going to visualize our vector by having, so I just dropped this line down here. And this is my angle theta, so I just imagine that this is our point if we drop this down to the XY plane. And we also have this angle here, which you can probably imagine better now since we have this angle over here, which tells us that that our line here is not on the YZ plane, it's on the XY plane. So if you're not exactly sure what I'm talking about, you can watch my video about 3D coordinate systems. So now we know that we have this green vector here, or we can just refer this to as vector V again. So now we have vector V. We want to find a way to represent vector V again. So we can still call this point A and still call this point B, and it's equal to vector AB. Now, as you can guess, we'll probably try to figure out the magnitude first. So the magnitude here is just going to be, so we're going to use the Pythagorean theorem twice. So we can drop an altitude like this. And we just figure out the x coordinate and the y coordinate. We can figure out this coordinate, and we have this coordinate and this coordinate, the z coordinate, and we use the Pythagorean theorem on these two coordinates that I circled, and we get the length of AB. So for the x coordinates, let's just assume that the x is 3 units, the y is 4 units, and the z is let's see. So the z is gonna be, let's say it's 5 units. So I have so what I want to figure out is root x squared plus y squared plus z squared, because if you think about it, AB is just gonna be root of root x squared plus y squared squared. So if we just cancel the square sign, we have this equation here. So if we plug the values in, we have 3 squared plus 4 squared, which is 25, and also 5 squared, which is 25. So that's root 50, which is 5 root 2. So AB is equal to 5 root 2. So the magnitude of vector V or vector AB is going to be equal to 5 root 2. Now we can also try to write this vector V without the magnitude, just with magnitude and direction, not just solely the magnitude. So as you can guess from the previous 2 examples of 1D and 2D vectors, we can write this with 3 numbers. So the x coordinate, so 3, the y coordinate 4, and the z coordinate 5. You can also write this as 3, 4, 5 like this. Or you can write this in brackets like that. 3, 4, 5. So this is our end of the video, and remember to like, subscribe, and share.